At this point, you have heard and read a lot about the difficulty of AI alignment and how AI models could become dangerous and pose existential threats to humanity. So you might be wondering, what is the kind of research that researchers are currently working on so that to tackle the challenges of AI safety. And this and the next week are exactly devoted to the two subfields of AI safety. The first this week, technical AI alignment, and AI governance next week. Broadly speaking, the goal of technical AI alignment is to solve the alignment problem. But what does this mean exactly? And the paper that you have for this week asks the question a little bit more specifically and in a little bit more conceptual, theoretical way of framing intelligence and trying to conceptualize AI alignment as a matter of first principles. So the question is, what are the design principles that we need so that AI behavior aligns with human values and interests as the systems become more autonomous and intelligent and powerful? So this is a first principles approach because, as you know, we do not have the models, but we're trying to devise the right principles that we will need to install in them as we're designing them, as we're developing the systems, but before the systems are out there available. And many researchers think that this is the safest way to go, unlike some other kinds of approaches that suggest that it's perfectly fine to do the engineering work, even if we do not have reliable alignment techniques. These researchers are less worried about the difficulty of the alignment problem, and they expect that as we do the engineering work, we will be able to resolve whatever challenges we face. And you may have different opinions on who's right and who's wrong, but for this week, we will concentrate on this idea of design principles beforehand, before the systems become available. Now, what are two problems that you'll read about in the paper? The first is that it's difficult to define AI objectives that reflect complex human values. This is something you've already read about. What is the complexity of human value? It's difficult to compress our preferences. It's difficult to specify utility functions that exactly reflect our human values. And this is something that you may have realized from your daily interactions with other people as well. And you may have experienced that in the various versions of miscommunications or failing to express exactly what you want, because sometimes we don't even know what we want, or we're not very good at communicating what we want with other people, or we're clarifying what we want on the way. So there is a lot of ambiguity in specifying human values. That's the first problem. The second problem that we're dealing with in AI alignment is that it seems hard to design systems that avoid negative unintended consequences, exactly in all those cases where the utility functions or the objectives have not been perfectly specified. And so it would be good to have some alternatives, some backups. So even if we fail at specifying our values accurately, we would not get really, really bad unintended consequences. And so you'll see the 8 research topics in AI alignment in the paper, which concern roughly these 2 problems and dive into them a little bit more specifically, especially trying to think about inductive ambiguity, identification, the ability of humans to exercise oversight upon AIs, robust human imitation, the ability of AIs to behave in ways very similar to humans and decision making. Then informed oversight, how well can human supervisors monitor AI actions, especially as we get to systems that are more and more intelligent and the tasks might become more and more complicated, respectively. The problem of generalizable environmental goals, which means that depending on the context, depending on the environment, the systems might be behaving differently. So we do not know how well the models will generalize depending on the context. And being able to think in terms of avoiding extreme solutions. So, for example, if the problem we have is to cure cancer, one solution the AI could come up with would be to eliminate all humans. And this would consequently eliminate cancer, but this is an extreme solution that kills humans. Also instrumentally useful for doing what we requested the model to do, which is to cure cancer. Okay, so that's an extreme solution we wouldn't want the model to find. Impact measures, being able to not have unintended high impact actions, kind of similar to the problem before. Mild optimization, just try again this sense of not doing extreme optimization, trying to do something a little bit more moderate, just what's enough for the model to achieve its goal. And averting instrumental incentives, which is what we mentioned before, sort of trying to remove AI incentives for self-preservation and resource control, which is what you saw in the Almohandro paper with the basic AI drives. So these are briefly the different areas that the paper talks about, and you can read about them in more detail and think about them with more specific context. Now, the other paper is concerned with exactly the kind of technical work that AI alignment, machine learning researchers are working on right now in technical AI safety, and in a very similar approach, and the problems are very similar in nature, and you'll see right now as I go through this table from the Unsolved Problems in ML Safety paper. The first question is, well, how do you create models that are robust? What does it mean? It's again this question about models that generalize well, regardless of the context. So you put them in an unusual situation and you're still able to predict how the model is going to behave, exactly because it's robust, it's more predictable, it's going to have reliable behaviors regardless of where you find the model. The second problem is, how do we detect malicious usage, and how do we ensure that the model cannot discover unexpected functionalities? So how do we know that we're properly monitoring the model? Which is again something that we mentioned before. How do we ensure this human supervisor oversight that is sufficient so that the model does not come up with new functionalities that the operator did not want. Third problem, alignment, which is a word you're all very familiar with at this point. How do we optimize for hard to specify human values? Again, the problem of the complexity of value. How do we install goals into machine learning systems? And finally, systemic safety, broader risks about how ML systems are handled in the bigger picture context, as you can think examples with cyber attacks. So these are the issues we have for the week, and it's interesting to consider how these subfields of technical AI alignment are in a way trying to deal with the same question, which is how to solve the alignment problem, but you see how it breaks down into different technical research directions and how more and more different challenges appear on the way to resolving these sub problems. And so it's interesting to think about the sub problems that essentially stem out of this question: solving the alignment problem, finding principles that ensure AI behavior aligns with human goals.